Let's talk about what might be the single most important company you've never heard of, ASML. They have an absolute total monopoly on the one piece of technology that makes our entire modern world possible, EUV lithography. That's the magic behind every single advanced microchip on this planet.
Okay, before we jump in, a quick but important note. This is a strategic analysis. We're here to understand how this monopoly was built. This is not, I repeat, not investment advice.
So the big question is, how? How on earth did one company, from the Netherlands of all places, build a fortress around the future of technology that no one can seem to breach? Well, it's an incredible story of mind-bending physics, high-stakes finance, and global geopolitics. Let's break it down.
To really get it, we're going to look at the four massive moats protecting ASML's castle. First, there's the one-of-a-kind technology itself. Then, its iron grip on the supply chain. After that, its deep alliances with its customers. And finally, the geopolitical forces that basically cleared the field of any would-be rivals.
All right, let's start with moat number one, the technology itself. ASML's EUV machine is, and I say this with zero exaggeration, the most complicated and sophisticated machine humanity has ever built. Period.
So how does this thing even work? Well, the process is just wild. Inside this machine, a super powerful laser zaps tiny droplets of molten tin, 50,000 of them every single second. Each hit vaporizes a droplet into a plasma, which then lets out this flash of extreme ultraviolet or EUV light. Now, the crazy part is this light gets absorbed by basically everything, including air. So you need this impossibly complex system of mirrors, all working inside a perfect vacuum, just to bounce the light onto the silicon wafer to etch the chip's design.
And when I say precise, it's hard to even wrap your head around it. Take the mirrors. An exec from Zeiss, ASML's partner, gave this analogy. If you scaled up one of their mirrors to the size of the entire country of Germany, the tallest bump on its surface would be less than a single millimeter high. I mean, think about that. That level of engineering is just staggering.
And these machines aren't just precise, they are colossal. A single EUV scanner weighs 180 tons. It is so huge and so complex, it takes 3 Boeing 747 cargo planes just to ship one. The sheer logistics of building and moving these things is, in itself, a huge barrier to entry. Now, all of this physical complexity is wrapped in a legal fortress. It's not just that they know how to build it, ASML and Zeiss have locked down the intellectual property. If you look at their patents related to EUV, they have more than the next 9 competitors combined. They've legally walled off the entire field.
And that leads us perfectly into the second moat, controlling the supply chain. Look, you can't build the world's most complex machine with parts you can just buy off the shelf. You need a whole ecosystem of specialized partners, an ecosystem that's just as unique as the tech itself. And the reality is, ASML has deals with the only companies on the planet that can make these critical components. Those unbelievable mirrors, only from Carl Zeiss. The light source, that laser system, only from Simmer and Trumpf. And just to be absolutely sure no one else could get their hands on it, ASML just went ahead and bought Simmer back in 2013.
What this creates is a situation that analysts call supplier lockout. It means that even if some brilliant competitor designed their own EUV machine tomorrow, they couldn't actually build it. There's literally nowhere to buy the parts. The suppliers are locked into exclusive deals with ASML, or they just physically don't have the factory capacity to serve anyone else. It's a closed loop.
Okay, on to the third moat, and this one is just brilliant from a business perspective. Customer lock-in. ASML's relationship with its clients isn't just about selling them a machine. They've ingeniously turned their biggest customers into their biggest partners and even investors.
Think about this. Back in 2012, EUV was still a massive, expensive gamble. So ASML did something pivotal. It went to its top 3 customers, Intel, TSMC, and Samsung, and invited them to invest directly in the company to fund the R&D. Together, they bought a 23% stake and pumped in almost 4 billion euros. They literally bought into ASML's success.
Because of that deep partnership, for a chipmaker like TSMC or Samsung to switch away from ASML today is, well, it's basically unthinkable. We're not just talking about the cost of a new machine. It would mean they'd have to re-engineer their entire multi-billion-dollar fabrication process, all their software, their workflows, everything from the ground up. The lock-in is absolute.
All right, this brings us to our fourth and, honestly, maybe the most fascinating moat,
the unseen hand of geopolitics, and the ghosts of rivals who tried and failed. You see, ASML's dominance wasn't just built. It was also shaped and protected by governments and the missteps of its competitors. Way back in the early 2000s, some of the key foundational research for EUV was actually funded by the US government. When it came time to license that technology, Washington said no to the Japanese giants Nikon and Canon, but they said yes to an American firm, which ASML then promptly acquired. That single move gave ASML a massive head start, and today, Western governments continue to protect ASML by blocking sales of these machines to China, kneecapping its most determined potential challenger.
And if you want a perfect example of what happens when you fall behind, just look at Nikon. In 2001, they were a leader in this space. But after being denied that critical US tech and facing the staggering cost of developing EUV on their own, they finally gave up in 2009. By the 2010s, they'd completely surrendered the high-end market to ASML. They couldn't cross the EUV moat, and they got left behind.
Now, Canon saw what happened to Nikon and decided not to even try to compete head-to-head on EUV. Instead, they took a totally different route with something called nano-imprint lithography, or NIL. This technology literally uses a physical stamp to press a pattern onto a wafer. It's an interesting idea and could be cheaper, but because it makes physical contact, the risk of defects is really high. Right now, it's a long-term high-risk bet, not a serious threat to EUV's dominance. So when you step back and look at the competitive landscape today, it's pretty stark. Nikon is out of the advanced game. Canon is off on a high-risk tangent, and China's state-backed champion, SMEE, is at least a decade, maybe 15 years behind and completely blocked by sanctions from catching up. There is simply no one else on the field.
So, after looking at all four of these moats, what's the big takeaway? The real key to understanding ASML's fortress is that these defenses don't just exist side by side, they're deeply, powerfully interconnected.
Think about how these all lock together. You have this unbelievably complex technology that's protected by a wall of patents. That tech requires an exclusive global supply chain that no one else can even access. That supply chain builds machines that customers have invested billions in and designed their entire factories around. And this entire, delicate system is protected by a geopolitical shield.
It's not just one advantage, it's a virtuous cycle. The better the tech gets, the deeper the customer lock-in becomes. The more customers they lock in, the more money they can pour into R&D and securing their supply chain. And the more critical they become to the global economy, the more geopolitical protection they get. Each moat makes the others stronger.
And all of this leaves us with one final, pretty sobering question to think about. For a company that holds the absolute keys to our entire digital civilization, what kind of force, whether it's technological, economic, or political, could possibly ever breach this fortress?